Okay, I'm George. I'm an AI research engineer from AgroKnow's R&D team, and I'm going to talk about the data collection platform that we're currently building in AgroKnow. I'm going to talk a little bit about the journey of a food safety record, which we are trying to monitor. First of all, AgroKnow is the food safety intelligence partner that extracts tailor-made data insights for the global supply chain. And a few words regarding the food safety. As you, of course, know better than me, food is recalled every day all over the world. The food safety authorities recalling unsafe to consume products, and our mission is to try to monitor them. So we have specific sources that we try to monitor and collect data, and we are trying month by month to enhance those kind of sources around the world. As told earlier, those kind of sources can be found around the world, and these are some of the countries that we're trying to monitor. From them, we're trying to collect specific food incident announcements. Here we have an example of a specific food safety announcement data source and authority. You see in the left picture the web page with many links, and you may see that there are some hyperlinks with blue. That if we click in each of them, we are getting forward to the right picture, which is a specific food recall. And this is the specific recall that we are trying to collect and extract the entities that have been announced in it. So you may think that web crawling is easy because if we have the specific sources that we'd like to monitor, that would be easy, but that's not exactly the case, because each specific food safety authority source announce incidents with a specific data format. For example, we have HTML formats, RSS, XLS, XMLs, and this is the first kind of difficulty that one may face if someone tries to monitor all of them data sources. So the first part of our platform that you see here, you see from the left to the right, the crawling layer, which is the layer, a module in Java, which tries to monitor all of the specific data sources that we have chosen. And the raw data persistence layer, which is a MongoDB instance, where the raw data are stored. And our transformer, AK transformer, which is a project in mixed Java and Python, because as we said earlier, each source has its own format, and we need the format, the properties, all of them to homogenize. And this specific module is responsible to harmonize them, and in order to follow our internal schema. So let's talk about what is important in a recall. There are some specific entities that we try to identify in each specific recall. The first of all is the ingredient, which is, if we ask the question, which was the main ingredient of the recalled brand. And you see here that in the example that we saw earlier, that in this specific recall, the ingredient is the hamburger buns. And we try to extract this entity and put it in a specific vocabulary, and we have already a fixed vocabulary, an ontology of various ingredients and how they structure in a hierarchical view. The second is the hazard. the hazard can be identified if we ask the question, which was the reason behind the recall. And you see here with a green color that we are trying in each of the specific food incident to identify the hazard. And in the same way that I explained before, to put it in the correct part of the ontology, in the hazard ontology in that time. Furthermore, we need to extract the supplier, which was the food companies or the food company involved in the recall. And we're trying here to employ specific name entity recognition techniques in order to identify the specific company or the specific companies. And we have a specific Neo4j instance that I will be showing later, where we try to connect all those entities, which companies relate to which companies in the food incident announcement. And we have some other entities that we would like to extract, for example, the brand, the date, and the origin, and all of them can be found in the specific parts of the announcement, but it's not the same for each data source, because some data sources announce incidents in a structured format, some in a semi-structured format, and some data sources announce the incidents in a totally unstructured format, for example, plain text. So we need to employ some other techniques to identify the specific entities. And of course, by integrating open source data like USDA and the others that you can see in this slide. Of course, these are not the only difficulties that one may face. There are various languages because we are talking of a global monitoring system, and the different sources may contain, of course, different languages. And in order to face this problem, we have the data enrichment layer, where you can see that we have some Elasticsearch instances, and we have a Yandex service in order to enrich our data that we need first translate. In order to perform the data enrichment, we have, as I said before, 3 dedicated Elasticsearch instances, which are used to perform the text mining on the top. Our vocabularies, multilingual names, and alternative names have integrated into the Elasticsearch. And once we have the raw text, we send it to Elasticsearch, and we ask the question, okay, for this specific text, for this specific plain text, does it contain any already known terms to Elasticsearch? If yes, then we're perfectly fine because we have identified the entities that we were searching for. If not, then we have here some scikit-learn and Keras services, which perform, in essence, name entity recognition task. And all this is wrapped up in the AK Enricher, which is a Java project. Of course, we have some other data, some laboratory test results, which can be found in 2 Cassandra instances, which are used because we're talking about a very big sample of numeric data. And on top of that, we have the data curation layer, because up to now, from what I have described, there is a whole automated process. However, because as you have already heard, we have some name entity recognition techniques, and we need to validate that the automated processes have correctly identified the data entities that exist in the specific text. So in the curation layer, we have some food experts that validate that our automated processes went well and returned the desired entities from all the texts. So this is an extra validation layer, the curation layer. Then we have the data persistence layer, consists of some Elasticsearch instances. This specific layer is contain the ready-to-use data, because in the other parts we had raw data, and this specific layer has the user friendly data. And you see that this is directly connected to the curation layer, because after the data have been curated, they are going into the data persistent layer. And we have we also have an NLP and analytics data layer, which can directly communicate to the data API. This specific layer allows the user to perform complex queries in order for the data to be served to the user. And in there, each Elasticsearch instance is used for translation data and multilingual labels. There are also some Python scripts that can perform name entity recognition and NLP tasks, and a Neo4j instance, which I talked about later, and it is used to construct the relationships of the companies that were identified in all the food safety announcements. I think that this was the last slide that I would like to present. Of course, yeah. Of course, if there are any questions, I would be happy to answer. Otherwise, I give the floor to Ine.
Yeah, thank you, George. There is one question in the chat from Ludger asking, in terms of numbers, how many recalls did you already analyze, and how many you plan to analyze in the future?
Yeah, we have many thousands of recalls that have been collected throughout this platform, and of course from all the data sources. And this is an ongoing process, and we are planning to. This is not going to end in a specific number, of course, because every day food incidents are announced, and if they announced in the specific sources that were monitored, we collect them.
Yeah.
Thank you.
Clear. Thank you. William, you also have a question?
I do indeed. George, what would you say is the most manual part of this infrastructure, this data collection system?
The most manual part is the data curation layer, because this is a totally manual layer, and has been added there in order to ensure that our data extraction has been done successfully. Because there are some automated processes, there are some vocabularies that we need to match with string matching, and some NER techniques. But this, as you may know, can fail anytime, and may return some results that are not consistent with the specific food safety announcement. And this is why we employ our food safety experts to validate that we have returned the correct instances, the correct entities.